Section 5.8, the quadratic formula. We're going to solve the quadratic equations using the quadratic formula, and we're going to use a discriminant to determine the types of solutions. So we have solved quadratic equations by graphing, by factoring, square roots, and also by completing the square. We have also found real and complex solutions using these methods. So the last method that we're going to do is going to be using the quadratic formula. So of course it's called the quadratic formula. I mean, this means that we can solve any quadratic equation using this quadratic formula. So even if we can factor it, we can still use a quadratic formula. We could complete the square or use a quadratic formula. So this is a nice formula that we're going to learn. Now the first part that I'm going to do is I'm going to derive the quadratic formula. If this part is a little hard for you to understand, that's okay. Just write it down. You don't need to memorize it. I'm not going to have you write it down for a test or quiz, but it's something that just is kind of helpful to see where this formula comes from. So the first thing I'm going to do is write down standard form for a quadratic equation. So ax squared plus bx plus c. Now, if I wanted to complete the square for this using variables, remember we said we don't like to have that linear term or the quadratic term with a number coefficient in front, so I'm going to divide out that a by each of my terms. So if I divide each of those terms by a, I would get x squared plus b over a x plus c over a. And then remember, when we complete the square, we take the constant term to the other side. So the constant term would be the c over a part. So we get x squared plus b over a x plus something to complete the square equals negative c over a plus that same number, again, to complete the square over here. So remember, when you're completing square, it's half your linear term. So b over a is half my linear term. So in this case, I get b over a. I want half of that. So I'm going to multiply it by a half, and then I'm going to square it. So this gives me b over 2a is half your linear term, and then squared gives you b squared over 4a squared. So this would be b squared over 4a squared. And I'm going to do the same thing on this side. I'm going to leave a little space in between, though, so I can write something there. Now for this, that was good because now I can factor my equation. So this becomes x plus, and then remember it's half your linear term when you're factoring, so b over 2a, and then I would have another one, so I'm just going to square it and skip that step, is equal to. Now for this next step, I'm going to combine my fractions. So remember that in order to combine fractions, I'm trying to get this together. I need a common denominator. So what's common between 4a squared and a? Well, 4a squared would be the common term, the least common denominator. That means I need to multiply this by a 4 to get that, and I also need another a to make the a squared. So this is going to help me write it as one fraction. So when I do that, I get negative 4ac, because remember you write the variables in order and the number in front, plus our b squared over 4a squared. Now I have it as one fraction, so then remember the next step is that we want to solve for x, so I want to get rid of that power of 2 that I have right here. So to get rid of that power of 2, I want to take the square root of both sides, and don't forget your plus or minus. So let's go up here and do that. So I get x plus b over 2a. I'm going to take the square root, so plus or minus the square root. I'm going to rewrite this equation that I have over here and write the b squared first, and put it in order. So this would be b squared minus 4ac. I just rewrote it all over 4a squared. Remember, we don't like to have fractions underneath a radical, so in order to get rid of that, I'm going to do a root on the top and root on the bottom. So I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over the square root of 4a squared. So the square root of 4a squared is really equal to 2a, so I'm going to put that here. And then the last step would be to solve for x and put the b over 2a on the other side. So x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since these have a common denominator, I'm going to go ahead and put it all over the same denominator. and I get x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So this right here is my quadratic formula. And like I said, you don't need to know all the steps to get there, but you do need to know this formula. So in class, we're going to actually learn a song to help you memorize it. So as I said before, this formula is a big formula because it helps us solve any quadratic equation. So you're going to want to highlight this in your notes because this is what we're going to be using in order to solve these equations. So this is an important formula that we're learning today. Now, whenever you're doing the quadratic formula, you must be in standard form. And remember, standard form is ax squared plus bx plus c. If your equation is not in standard form, that means set equal to 0, so we'd want to make it equal to 0, you're going to want to put it in standard form first, and then you can use the quadratic formula. And notice for the formula, we have b, we have an a, we have an c. Where do these numbers come from, the b, a, and c? It comes from the a, b, and c from your standard form that we've been using to find vertex of our equation when it's in standard form. So going to these problems, we're going to use the quadratic formula to solve each equation. So the first thing I do is write down my a, which is 5, my b is -1, and my c is -4. So this was already in standard form, so I didn't have to put it in standard form. If it wasn't, I would do that first and set it equal to 0. So now I have my a, b, and c. All I have to do is put it into my equation. So I always like to rewrite my equation just to make sure that I know what it is. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that means I need to put this into my equation. So I get x is equal to, my b is -1, so I have -1, plus or minus the square root of -1 squared minus 4 times my a, which is 5, times my c is -4. And notice I put those all in parentheses. Whenever you plug in numbers, it's a good habit just to put it in parentheses. And then 2 times a, which is -4 in my denominator. So now I want to evaluate this. And usually the way that I evaluate this is I do the radical, what's underneath that first, and then I'm going to simplify it. Okay, so this is how I would plug it into my calculator. So I'm going to do what's underneath the radical first. So we have, and I do it without the root, and then I put the root back in. So -1 squared minus 4, and then times the 5 times -4, enter, and I get 81. So then that means over here I'm going to write x. So x is equal to 1, because -1 becomes +1, plus or minus the square root of 81, all over -4 times 2 gives me -8. And I like doing that because we're going to learn that what's underneath the radical, which is called the discriminant, helps us figure out how many solutions we're going to have. So that's why I'm writing it like this. So now that I have this, I can actually simplify. I know the square root of 81 is really 9. So I get 1 plus or minus 9 over -8. These are all like terms. So since they're like terms, that means I actually need to find my two solutions that I have. So, oops. I'm going to go ahead and make this a little smaller. So I'm going to find my two solutions. So one of my solutions is going to be x is equal to 1 plus 9 over 8, and the other solution is x equals 1 minus 9 over -8. So again, whenever you have like terms, you want to combine those so that you can get your solution. 1 plus 9 is going to give me, oh crap, and I just realized that this should have been not -4 because it's over 2a. So I should go back here. Sorry, I didn't realize I did that in the beginning. So we need to erase these denominators here. And my A value is 5. I accidentally wrote my C value when I did that, so this should have been a 5 here. So this would be 10, 10, 10, and 10. So sorry about that. Now we have 1 plus 9, which is 10, and 10 over 10 gives me a value of 1. And then here we have 1 minus 9, which gives me negative 8 over 10, and negative 8 over 10 reduces into negative 4/5. So that means my two solutions are going to be x equals 1 and x equals negative 4/5. And that's what I would write down. Now, if you had a root in your equation or something else, then you could just simplify it and then write your two answers. All right, so now we're in the next problem. We're going to do this again. So now I have a quadratic equation. It's in standard form. I want to use the quadratic formula. So for this one, we have A value is 3, B is 23, and C is 40. So for this one, when I do the problem, I'm going to plug it in for my A, B, and C values. So we get x equals negative B plus or minus the square root of b squared, which is 23 squared, minus 4 times a times c, all over 2a. I'm not going to make the same mistake I just made a minute ago. So my a value is 3. So now I want to simplify this, so I'm going to get my calculator, and I'm going to do all that in my calculator, what's underneath the radical. So we get 23 squared minus 4 times 3 times 40. And this is what I got underneath my radical. Oh, I didn't realize I squared that twice. Let's try this again. Oops. So if I go back to the beginning of the problem, I accidentally squared 23 twice. I was going to say that's a very large number. It's hard to use these calculators on here sometimes. All right, delete, delete, enter. That looks much better. So 49. So now when I write this down, I have x equals negative 23 plus or minus the square root of 49 all over 2 times 3, which is 6. The square root of 49 is 7, so I get negative 23 plus or minus 7 all over 6. So that means I have two solutions, and they're like terms, so I can find them. Negative 23 plus 7 over 6, and x equals negative 23 minus 7 over 6. So when I do this, I would end up with two answers, x equals negative 8/3 and negative 5. So of course you guys can do that math. Now, if we look at this next one for C here, the first problem I have is that it's not in standard form, so I want to put it in standard form. So I can take everything to the negative 2x squared side, or I can take the negative 2x squared to the other side. I usually like working with positive quadratic terms, so I'm going to add the 2x squared to the other side. So I would get 2x squared plus 4x plus 3 is equal to 0. So now I can solve. So this a value is 2, b is 4, c is 3. So my formula, x equals negative b, which is negative 4, plus or minus the square root of b squared. So 4 squared minus 4 times 2 times 3, all over 2 times my a, which is 2. So when I do this, I get x is equal to negative 4 all over 4. I would want to figure out in my calculator what that discriminant part is, what's underneath the radical. So underneath the radical actually simplifies into the square root of negative 8 when you do it in your calculator. So because of that, remember, negative underneath my radical, that means I'm going to end up with imaginary solutions, which is okay. So for this, we get x is equal to negative 4 plus or minus, this becomes I times the square root of 8. And then remember, 8 reduces into 2 root 2, so this would be 2I root 2, so that's what I'm going to use. all over 4. And of course, then if you look at this, I know I can simplify this because 4 goes into 4 and 4 goes into 2. So since it can go into 2 only twice, I'm going to simplify it by 2. So when I do that, I end up with x is equal to, so this would be negative 2 plus or minus I root 2 over 2. And I can't simplify anything because those aren't like terms. So these are going to be my two solutions. And of course, my two solutions are imaginary. So that means they're not going to cross the x-axis at all because they have that negative underneath the radical. So why don't you guys go ahead and do D and see if you can work out this problem on your own, and then we'll look at it in class together. On the back side, so you hear me talking about this discriminant value. So the discriminant is the what's underneath the radical. So it's the b squared minus 4ac part. That is what the discriminant is. And the discriminant is helpful because it helps us determine the type and number of solutions for a quadratic equation. So helps determine the type and number of solutions for a quadratic equation. So the type of solutions is either a real solution or imaginary solution. So when our discriminant is greater than 0, so if like we go back to those other problems, the discriminant for A that we did here was root 81, so 81 was the discriminant. So it was positive, and notice that my solutions were real. And if we go to this last problem C that we just did, the discriminant here was negative 8. Because it's negative, notice I got two imaginary solutions. So that's what I'm talking about when I'm talking about the discriminant. So when it's greater than 0, you're going to have two solutions. So two real solutions. And if we were to graph that, that means that your graph would cross the x-axis in two places. So we've talked about that before. So it just looks something like this. You can just copy those graphs down. So you had two x-intercepts. When your discriminant is equal to 0, so that means what's underneath the radical is 0. Well, the square root of 0 is 0. So if you do plus or minus 0 in your quadratic formula, you would only have one answer. So you're going to have one real solution. And you get one real solution when you have one x-intercept. And that's when your vertex is on the x-axis. So let's go ahead and write that down. So when the vertex is on the x-axis, you get that 1. And then the last part we have is this formula right here, which is b squared minus 4ac is less than 0. So when it's less than 0, you have no real solutions. Instead, you have two imaginary solutions. And that's when your graph doesn't cross the x-axis, like right here. So doesn't cross the x-axis. So for example, it says determine the type and number of solutions. How many times does the graph touch the x-axis? So for this one, since it just says determine the type and number of solutions and how many times we cross the x-axis, we don't have to do the entire quadratic formula. If instead the question said to solve and find the solutions, then I would. But in this case, I don't. So A is equal to 1, B is equal to 6, C is equal to 8, and we know the formula we're using is b squared minus 4ac. So in this case, I get 6 squared, because that's my b, minus 4 times a, which is 1, times c, which is 8. So when I solve this, and I get 4. So 4 is a real number, so that means I'm going to have two real solutions. That means I would have 4 underneath the radical in my quadratic formula, and the square root of 4 is 2, so that's how I have 2 of the solutions. And that means it's going to touch the x-axis twice. So if I go over here to B, same thing. My A is 9, my B is negative 24, and my C is 16. And again, if I wasn't in standard form, I would make sure to put my equation in standard form. So b squared minus 4ac gives us our discriminant. And I should have said that this was the discriminant right here, 4 for the last one. So in this case, I get negative 24 squared minus 4 times 9 times 16. When I do that, I get 0. So since my discriminant is 0, if I take the square root of 0, it's just 0. That means I'm going to have one real solution. And that means we only touch the x-axis once. And for the last one, same thing. A is equal to 5, B is negative 4, C is equal to 3. So B squared minus 4AC. Notice I write that down each time because it helps me memorize what it is. I get negative 4 squared minus 4 times 5 times 3. And when I do this out, I get negative 44. And because of I get negative 44, that means that's my discriminant. So underneath my in my quadratic formula, underneath the radical, I would get negative 44. So that means that my solutions, when you have negative underneath the radical, are going to be imaginary. So 2 imaginary solutions. And that means it doesn't cross the x-axis. So there's no real solutions when that happens. So let's look at this last problem that we have here. It says, suppose a player makes a scoop that releases the ball with an initial velocity of 34 feet per second. The function that's given here models the height, h in feet, of the ball in time in t seconds. Will the ball ever reach the height of 20 feet? Will the ball ever reach a height of 15 feet? So for our equation, we have negative 16 t squared plus 34t. And we want to figure out if the ball is ever going to reach 20 feet or 15 feet. So that means when our height is equal to 20, will I be able to reach that? So in order to tell whether or not I'm going to be reaching this height, you're trying to look at your graph for this. And if you look at your graph, one thing that we can do is solve it for the equation for t and figure out if we can get some kind of time. So the best way to do this, instead of doing the whole problem out using the quadratic formula, I am going to do the b squared minus 4ac to tell me if I'm going to have real solutions or not. So when I do this, I would first put it in standard form, so negative 16t squared plus 34t minus 20. And if I do this out, I would get my b squared would be 34 squared minus 4 times negative 16 times c, which is negative 20. If I do this out, I get the discriminant equal to negative 124. So because of that, if I were to do my quadratic formula, I know that I'm never going to get a time that's going to allow me to have an answer to reach a height of 20 feet. So this means that the ball will never reach a height of 20 feet. And then you would do the same thing with 15. So if I plug in 15, I'm just putting on the other side. So I would put it in standard form first. So A is negative 16, B is 34, C is negative 15. So B squared minus 4AC. My B is 34. A is negative 16, C is now negative 15. And when I do this out, I get 196 underneath my radical for my discriminant. So that means that my ball can reach this height. So yes, the ball can reach a height of 15 feet. Now, if I wanted to figure out the time at which the ball reaches 15 feet, then I would actually do the entire quadratic formula out and solve. Or if we go to our graph in our calculator, I'm going to put this into my graphing calculator. So I put this in my graphing calculator, y equals. I'm going to look at the graph. So I hit zoom 6, and it's not a very good window because I'm not really seeing the top values for y. So I'm going to change my window y maximum to maybe, let's say 25, because we were looking at 20 feet and 15 feet for the height. Okay, so I forgot the x, so I put the x into my equation. So then I'm going to hit graph. And here's my graph right here. And something I haven't showed you guys yet is that you can find the max or min by doing second trace. Notice I have a minimum here and a maximum. So that would be a maximum vertex since it's opening down. And notice it has left bound and right bound. So something to the left of where I think the vertex is would be somewhere over here, enter. Something to the right would be on this side, enter. And notice the two arrows right here are pointing to each other for guess, and hit enter. So that gives me this maximum value that I have. So I have a maximum of 18, and that's another way that I can tell right away that, well, because the maximum on my parabola is only a height of 18 feet, a little bit more than that, I know that I can't ever reach a height of the 20 feet, but 15 feet I can. And then, of course, like I said, I could find what height, what time that would be by using the quadratic formula and solving.